And now it's time to apply everything you've learned about gases to the gas laws. The gas laws I'm going to do in two videos. One, I'm going to show you the basics and the relationships between pressure, volume, and temperature. And the second, we're actually going to solve gas law problems. Let's start off with the basics. First, there's Boyle's Law, named after Robert Boyle. Boyle's Law states that if you change pressure, the volume will change when the temperature is constant in a very predictable manner. If you increase the pressure, the volume will decrease. And the reason is that as you increase pressure, you're going to squeeze those molecules closer together and the volume will go down. You're squishing the gas. This, of course, is an indirect relationship. Now, if the pressure is 2 atmospheres, and the volume at that 2 atmospheres is 2.0 liters, that puts us right here. If I double the pressure from 2 atmospheres to 4 atmospheres, the volume will be cut in half from 2 liters to 1.0 liters. So in other words, if the new pressure is 4.0 atmospheres, the new volume will be 1.0 liters. This is your indirect relationship. If you double the pressure, the volume will be cut in half. Now, if we cut the pressure in half to 1 atmosphere, the volume will double to 4 liters. And it gives you a graph that looks like that. A nice indirect relationship. If you take pressure 1 and volume 1 and you multiply them together, you get a number, 4.0. If you take pressure 2 and volume 2 and multiply them together, you get the same number, 4.0. Since pressure 1 times volume 1 equals 4, and pressure 2 times volume 2 equals 4, that means pressure 1 times volume 1 equals pressure 2 times volume 2, leading to the formula for Boyle's Law, P1 times V1 equals P2 times V2. What this means is that whatever the initial pressure and volume are, when you multiply the final pressure and volume together, you'll get exactly the same number. You could be asked to solve for any of these variables. We'll do that next. Charles' Law, named after Jacques Charles, is the relationship between the volume and temperature of a gas at constant pressure. In other words, we have a piston with fixed pressure on it. As we heat it, well, what happens to gases when you heat them? Well, they expand. And as they expand, the temperature will change. As the temperature on a volume of gas is increased, the volume will increase because gases expand when they're heated. This is, of course, a direct relationship. The math is going to be a little different than in the indirect relationship of Boyle's Law. Now, if volume goes up from 1 to 2 liters, if the initial temperature was 200 Kelvin, in order to double the volume, we need to double the temperature. This is why we need to work in Kelvin, because only Kelvin starts at 0. Celsius doesn't. So if you're given Celsius, you must always convert it to Kelvin. So at 200 Kelvin, the volume is 1.0 liters. At 400 Kelvin, the volume is 2.0 liters, leading to a nice direct relationship. If you take 1 times 200, you get 200. If you get 2 times 400, you get 800. So multiplication isn't going to get it done. But if we take 1 over 200, and then we take 2 over 400, notice that they simplified the same thing. 2 over 400 simplifies to 1 over 200. So this time it's volume divided by temperature, volume divided by temperature. Whatever volume 1 is divided by temperature 1 is, volume 2 divided by temperature 2 will always come out to be the same thing. You could be asked to solve for any of these variables. Final relationship is Gay-Lussac's Law. It's the relationship between pressure and temperature when volume is held constant. This law is named after Joseph Gay-Lussac. This law assumes you have a container whose volume can't change. When you increase the temperature, the molecules are going to pound off the container walls that much faster. Twice the temperature, twice the pressure. 3 times the temperature, 3 times the pressure. So as the temperature increases, if the gas is not allowed to expand, the pressure will increase, making it a direct relationship. Just like in Charles' law, being also a direct relationship, when the pressure goes from 1 atmosphere to 2 atmosphere, that was caused, if you want to double the pressure, that's caused by a doubling of the temperature. From 200 Kelvin to 400 Kelvin. At 200 Kelvin, it only exerts 1 atmosphere of pressure. But if you double the temperature, the molecules on average will be moving twice as fast, and therefore exert twice as much force when they bounce off the container wall, doubling the pressure. Now, because this is a direct relationship, the equation is going to be very much the same as Charles' law, the other direct relationship. If you take pressure divided by temperature, P1 divided by T1, and then P2 divided by T2, you're going to come up with the same value. 1 over 200 and 2 over 400 come out to the same thing. So the equation is P1 over T1 equals P2 over T2. You can combine these gas laws together into one combined gas law, which you can use instead of 3 separate gas laws. In fact, you can get these 3 gas laws from this combined gas law. Or you can use all the variables. Here's how it works. Charles' law is P1V1 equals P2V2. Charles' law is V1 over T1 equals V2 over T2. Gay-Lussac's law is P1 over T1 equals P2 over T2. Well, since pressure and volume are multiplied by each other, and they're both divided by temperature, we could combine all 3 of these gas laws into one gas law. If something is held constant, you ignore it.